Let's start with the esophagus.
Sounds good.
And you can draw some generalizations using the esophagus that apply throughout most of the GI tract.
Okay.
Want to talk us through them?
Yeah. Well, so first, we've seen the esophagus before. This is actually a different specimen. We'll quickly review the specimen that we saw in Foundations Lab on the epithelium after this one. But here's another view of another specimen from the esophagus, and we see very clear distinction in the staining of different layers. So up top here, near the luminal surface, or at the luminal surface, we have a mucosa defined by a broad epithelium. And then down here, there's a lighter staining region. Notice the dense basophilic staining of the mucosa. Here's a lighter staining region of submucosa. And then we get into a dense eosinophilic muscularis propria
/ externa.
Bingo.
It has two names.
Why use one name when you can use two?
When you can use two.
Exactly. Let's zoom in a little.
And then the whole outer thing is wrapped by a serosa or an adventitia.
Indeed. We will we'll eventually see a very thin, some evidence of a fourth layer all the way on the outside, the serosa or adventitia.
So that theme of mucosa, submucosa, muscularis externa / propria, and serosa and or adventitia, one sees throughout the GI tract, beginning to end.
Right.
It'll vary in its composition, but that's the four layers that are constant.
We're going to be looking for those four layers basically each time.
Yeah. So you start with the mucosa.
Zooming in, let's go to 10x. And here's what we see. From the apical cells of the epithelium down to a little strip of muscle here called the muscularis mucosa. That defines the very bottom edge of the mucosa.
Yeah, so it's not just epithelia on basement membrane. You've got this little strip of smooth muscle underneath.
Right.
Which serves to move things around. It's got a little bit of movement structure.
You just identify that as smooth muscle from here? That's sharp eye.
I'm good. Let's start at the top. Let's look at the epithelium. I see nuclei even at this low power.
Yep. How about 20x? Are they more obvious now?
You see more nuclei at the surface.
Right here. Yeah. These cells are alive.
They are. So it's non-keratinized.
Yes.
Stratified, many layers.
Squamous.
And squamous at the top.
Yeah.
Non-keratinized, stratified, squamous epithelium.
Nigel, I just can't help but notice also, look at the basement membrane just undulating up and down and up and down. It's almost as if this epithelium is trying hard to stay hooked onto
what's below
the layer below.
Yeah, it's Velcro. It's trying to do a Velcro thing. It's a theme we come across when we do skin as well.
Because
you don't want any friction or movements moving the layers over each other.
Yeah, imagine something sliding across the surface of the esophagus here. That might put a shearing force, apply a shearing force that would then cause the epithelium to abrade or slide back and forth over the underlying tissue. So this helps hook us in and keep us attached, right?
Yeah, and this actually is one of your early defense mechanisms, where you have non-keratinized stratified squamous, or any form of stratified squamous. It really says that there's physical pressures on the luminal side or the outside if it's skin.
It's built anticipating lots of forces. Yeah.
It's built anticipating that we eat solid food, not just liquids.
Right. Yeah.
Because the solid foods, as you swallow it, are still pretty solid, and they could rip the top layers off, so they're going to get replaced quickly. There's a high turnover there of cells.
I mean, if I'm grinding up some tortilla chips and then swallowing them, you don't want that stuff sliding past here and just like slicing you got a little thin monolayer of cells. That's not going to last.
Yeah.
So you have this big, thick, structurally sturdy, stratified squamous non-keratinized epithelium.
And it's a general rule wherever in the body you see stratified squamous epithelium, you're looking at a protection mechanism.
Right, something that can resist substantial physical forces. Yeah.
So that covers that. You said it goes down as far as another layer of muscle down here.
So there's a thinner layer of muscle. We call this the muscularis mucosa. Let's zoom in and make sure that we really are looking at muscle tissue. We can see fascicles of muscle fibers cut in cross-section. Here's some that are angled a little differently. They sort of, you see a little vertical rise in vertical dimension to those cells right there. Just looking at them in cross-section, I see lots of very small profiles, and some where we happen to have catch a nucleus. It's going even more here to 80. Some where the nucleus tends to dominate the whole small profile. The nuclei seem to be relatively well centered. They're certainly not shoved out peripherally. So,
and there's
what do you think?
One nucleus per cell, big round nucleus. We go with smooth muscle on that one.
Yeah, small cells, mononucleate, and with a centered nucleus. And if we were to see some of these cells in longitudinal section for their entire dimension, their entire longitudinal axis, they would be very long and skinny and spindly. Okay. Yeah. So smooth muscle.
We see lots of little blood vessels there now as well.
Indeed. Yeah, there's one right there.
Little capillaries there. Yeah. And so below that, that's the edge of the mucosa. Then we move into the submucosa, the below the mucosa bit.
I'm going to drop out to 20x so we can see the entire submucosa in one eye span.
Yeah.
And here it is.
Yeah. A lot of connective tissue, a lot of collagen fibers.
Just collagen streaming back and forth here with larger blood vessels. Yeah.
Blood vessels there.
Coursing through as well.
Yeah. And you're going to find the nuclei of autonomic nervous system nerves in there sometimes.
That might be a difficult spot, but it is possible to
find
them.
They should be there.
Hold on.
Ooh, little one. He thinks he's onto something.
Maybe.
What do you think? Type of thing, yes.
Right there?
Possibly.
Yeah. Okay.
And that is...
You're asking me to name it?
I was prompting you, yes. That is the name of the plexus.
There's an Auerbach's and a Meissner's, and I'm going to go ahead and go with Meissner's.
I think we both agree on that.
As the one up near the muscular
Absolutely, yeah. It's Meissner's plexus. So these are autonomic nerves, and those little cell bodies are sending their neurons out to that muscle of the muscularis mucosa.
Okay.
And help drive it to contract and relax. And that gives a little bit of fine movement to the mucosa. Not so important here, but when you get further down, it helps move other parts, the villi, a little bit of movement to help mix food.
Are you talking about peristalsis and segmentation?
No.
Well, what are you referring to?
I'm talking about movement of the villi themselves.
I don't think they're motile.
Well, they get a bit of wiggle.
Wiggle?
Sure.
Okay.
It helps mix and move food around so it doesn't get trapped between the villi.
Really?
Oh, yeah.
So the muscularis mucosa, which is relatively flat compared to the curving surface of the formed by the villi.
We're getting ahead of ourselves, dude.
They wiggle back and forth.
That's what I've read. I've never seen it personally, but it's what I've read.
All right.
So we have nervous system in there. We have connective tissue.
Right.
We have muscle on either side.
Muscle here, and more muscle down here.
And so, what's the point of the submucosa?
It's a connective tissue layer separating our mucosa from our large muscularis propria / externa, and it certainly supplies a route for blood vessels and nerves.
It does indeed. I think of it as partly as being a route for the blood vessels and nerves, and also as a damping system.
Okay.
A sort of a protective damping system. We're going to find these big muscles on the outside that are going to contract and drive peristalsis and swallowing in the case of the esophagus.
Okay.
And it helps damp those sort of pressures away from the mucosa.
Like bed springs.
Yeah, sort of. I like that. That's a good one.
Okay.
So that's the submucosa. Let's move on to the muscularis externa.
And then look at this. And I just want to comment on, note that we have this breadth of muscularis mucosa up here, sort of smaller strip of smooth muscle as we identified it. And then down here, look at this. I mean,
huge
that's a pretty
chunk.
Monstrous layer of muscle.
But 2 layers of color.
All right. So this constitutes the entire muscularis propria. And then there are 2 sublayers. So let's zoom in to, say, 20x and see what we see looking in a little closer. This is the boundary, the transition between those 2 sublayers. And we see the fascicles are cut a little bit differently here versus there. There is an orientation that we expect to find throughout most of the GI tract where we have inner circular muscle wrapped circumferentially around the tubing, around the lumen, and an outer longitudinal muscle that runs down the long axis of the tubing. I don't see a perfect right angle distinction here. These smooth muscles up here, smooth muscle cells certainly look like they're cut more in cross section. And down here, I think we can find some evidence of them looking like they're cutting.
There are other
too.
sections where we can emphasise that.
Sure.
Just go back a second, because the other
Okay.
thing I would say is that what we have here again, we were looking for nerve before. We have a lot of nerve and cell bodies here.
This layer has a lot of
All
nerve.
of this, it does indeed. And this is that other plexus you were talking about, Auerbach's plexus. Auerbach's.
Yeah.
So these neurons, these cell bodies, will project their little axons out to drive the smooth muscle of the inner circular and outer longitudinal components of the muscularis mucosa.
Right.
And this is your peristaltic movement.
So squeezing and pushing?
Squeeze and push.
Okay.
It's the story of the GI tract, you'll find.
Now, it just occurs to me, we're using these eponyms, and, historically we've kind of learned a lesson about that, right? There's some hazard there.
There's some moral hazard with eponyms, but
So, do we have some non-eponymous terms? Like, can we call this the myenteric plexus of autonomic nerves?
the myenteric plexus of Auerbach, we can call it.
Oh boy. Let's
That's the full name.
let's do as much work as possible to name this
Yes.
plexus.
It's still generally referred to it. Nobody's found any dirt on Auerbach yet.
Okay. Well, when it comes, we're going to end up calling it the myenteric plexus. What's the one up top? Is it mucosal?
It'd be submucosal plexus. It's in the submucosa.
The one we did see a little batch of nerve in the submucosa. That's right.
Yeah.
All right.
So it may well be, but that's for the future. Just for now, we've got some really
That's a
good
nerve.
chunky nerve.
That's right.
And it's between those two layers of muscle. That's the place you find it.
Right, and you can even see the change in the density of the staining there. It's
Yeah.
much kind of lighter and pinker.
It's rather beautiful, actually.
Yeah,
As a
lavender.
nerve sort of dude, that's really pretty good.
Yeah.
So let's now move out through the
Okay, I'm gonna-
outer longitudinal layer. And this is something you just learned that, don't you? Inner circular, outer longitudinal.
right.
It's just a fact of
Right.
life all the way through the GI tract.
Yeah, there's a mnemonic loci, like the word, for plural of locus. That's the longitudinal is outer and the circular is inner.
Oh, okay.
And then here, are we going to look for the fourth layer?
Just
now?
look for the fourth layer, which is the serosa.
Okay, so we got to drop down below our muscularis externa, and we're looking for ultimately a very thin, potentially a monolayer of cells that would form the adventitia. The adventitia would be connective tissue. If we actually had a serosal layer, that would evidence itself in the form of a monolayer of mesothelial cells. I'm not sure for the esophagus, depending on exactly where we are, it would probably be adventitia. We're in the
At this
posterior
point, yeah.
mediastinum, unless we've dropped below the diaphragm and we're actually in the abdominal cavity, which is
Yeah.
sort of, it's a very short stretch of esophagus.
There will be other places to see a serosa.
Yeah, but in any case, we can certainly see here a distinction. This is the end of the muscularis propria, and now we're on to other tissue, likely adventitia, connective tissue.
Right. Okay. Well, I think that's a good start for breaking down the four layers.
Sure thing.
Should we take a quick look at the other slide, esophagus slide that we've got?
I mean, it's just let's do a little nostalgic return.